Hi to everyone. Our next batch of learning has to do with conic sections. And I'm actually going to lecture on 8.1 and 8.2 together. And the order will look like this. We're going to take a look at circles, then we're going to look at ellipses, and then we'll backtrack to parabolas. If you're looking for references in your textbook, circles and parabolas are in 8.1. and the ellipses are in 8.2. But because circles and ellipses are so closely related, I would like to talk about them out of order. So we're going to start with something that I think you already know. And what I think it is that you know is a basic circle. So the basic circle that we know is x squared plus y squared is r squared. And we learned this earlier in the semester. It really is just the Pythagorean theorem. And we have a circle that has a center at the origin. And the circle that we know is x squared plus y squared is r squared. And we learned this earlier in the semester. It really is just the Pythagorean theorem. And we have a circle that has a center at the origin and a radius that's equal to r. So, for example, I expect that students should be able to graph x squared plus y squared is equal to 16 because they recognize the center is at 0, 0, and the radius is the square root of 16, which is 4. And so a simple sketch, you'd go to the right 4, you'd go to the left 4, you'd go up 4, and you'd go down 4, and then you just make a pretty little circle going through those 4 points. And your center is here at 0, 0. Excellent. Now, the next step from that is a circle that's been translated. So perhaps something like this. Can we graph x minus 2 squared plus y plus 4 squared is equal to, let's say, 25? So with what we know about translations, this is going to move right 2 units, and this piece will make us move down 4 units. And so what we've done is we've taken the center 0, 0 and we've translated it to the center is now at 2, negative 4, but our radius is still going to be the square root of that 25. which is 5. So a sketch of this circle would start off with simply plotting the center at 2 and -4, and then from there going to the right 1, 2, 3, 4, 5 units, going back 1, 2, 3, 4, 5 units, and then going up 5 and down 5. Taking our pen and connecting those 4 dots, we get a pretty decent circle out of that. Okay, well, those 2 examples are pretty basic, and probably what we would like is to write up something called the standard form of a circle. So let's do that. Standard form of a circle. And it's just simply x minus h squared plus y minus k squared is r squared. And we need to remember that hk is where our center is, and r is our radius. So one of the skills that we need from this section is is to be able to write an equation for a circle. And so let me just make a list of some of these skills. 1, can you write an equation for a circle if I give you the radius and the center, if you're given a graph, and if you're given the endpoints of a diameter. And then the other skill we'll need is, can you write an equation for a circle in standard form? So that'll be the last one that we practice. So let's try this. Taking an example, write an equation for a circle in standard form. So that'll be the last one that we practice. So let's try this. Taking an example, write an equation for a circle with the center at 4, -5, and the radius is the square root of 7. So anytime you're not sure of how to work something, you should always just simply write the formula down first and fill in what you know. So we know x minus 4 squared plus y minus a -5 squared is equal to the square root of 7 squared. And the cleanup to that, the x minus 4 squared looks great, but I can rewrite the y's as y plus 5 squared, and then the square root of 7, when you square it, gives you 7. So here we have our final answer, like so. All right, let's try again. Second example. Our second example is to write an equation from an actual sketch of a graph. And so I'm going to draw my graph not on the grid actually. So I'm going to tell you that this is at 1, 1, and then there's a point over here at 4, 1. And so here's a circle, and I would like for us to write an equation for a circle. but you've got to tell me where is the center and then how much is the radius. So from the graph, you can see the center is at 1, 1, and the radius is the distance between any point on the circle and the center. So that distance would be 3, so we can see that here. And now we're finished. We're ready to just simply say, well, the equation would be x minus 1 squared plus y minus 1 squared is equal to 3 squared, which can be written as x minus 1 squared plus y minus 1 squared is equal to 9. So far we're thinking, hey, you know what, this circle section is pretty good. Like, I'm feeling pretty confident in this section. I like it. So can we make it any harder? Let's see what we've got. So in our next example, write an equation for a circle. If the endpoints of the diameter are 5, -2, and 7, 4. So if you were to plot radius on your graph, that's a terrible circle, let's try that again. If you were to plot that on your graph, maybe you would have something like here, this is at 5, -2, and over here, this one's at 7, 4. And what we want is the center of the circle, which means we need this midpoint here. And then we would also need the radius. So we need the center, which is going to be our HK, and we're going to need the radius, which is half this distance. So the distance formula is just simply the Pythagorean theorem. It's the change in the x's squared plus the change in the y squared, square rooted. So the x's go from 7 to 5. The y's go from 4 to -2. And so the distance would be the square root of 2 squared plus, that's a 6 squared. So that's the square root of 40. Now the radius is half that distance. And then you need the midpoint formula to find the center. And so the midpoint formula is the average of the x's and the average of the y's. So if I take the two x's and add them together, I take the two y's and add them together, I'm dividing both of those sets by 2. I get 12 over 2 and 2 over 2. And so my center is at 6, 1. So to write this up, I have x minus 6 squared plus y minus 1 squared is equal to r squared. Now, I purposely didn't clean up that distance that I found because I knew I was going to square it. So I'd get a 40 over a 4. And so my final answer is going to look like this. X minus 6 squared plus y minus 1 squared is equal to 10. Okay, 40 over a 4 squared at 12 over 2, average of the x's and the average of the y's. So if I take the two x, x's and add them together. I take the two y's and add them together. I'm dividing both of those sets by 2. I get 12 over 2 and 2 over 2. And so my center is at 6, 1. So to write this up, I have x minus 6 squared plus y minus 1 squared is equal to r squared. Now, I purposely didn't clean up that distance that I found because I knew I was going to square it. So I'd get a 40 over a 4. And so my final answer is going to look like this. X minus 6 squared plus y minus 1 squared is equal to 10. Okay? Cool. All right, so we've done a pretty good job with our to-do list. The last piece would be to write a circle in standard form. But I've been talking about circles this whole time without really even introducing a definition. So perhaps I should ask you to write a definition. But a circle is a set of points, of all points, equidistant from a fixed point. And that fixed point, of course, is the center of the circle. Okay, so last skill, should be example 4, yes. Our last skill is going to be how to write an equation if it doesn't come in standard form. Example 4, suppose I have x squared plus y squared minus 10x plus 16y. And let's just say that that is equal to 11. Now, that by no means is written in the form we wanted. We want a group of x's squared plus a group of y squared equals some number. That's our goal. So what we do is we just regroup the x's, leave a space, group the y's and leave a space, and if the number isn't already over on the right hand inside by itself, we'll move it here. And then we're going to do a process called completing the square. We're going to take half of this negative 10 and square it. So that would be negative 5 squared. So we're going to add a 25 right here. We're going to do the same process with this 16. We're going to take half of the 16 and square it. So that's going to give us an 8 squared. We're going to add a 64. But this is an equation, so I have to add a 25 and add a 64 to the other side. So now on the right-hand side, what do we have? I think 100, but let's double check. That's 36, yes. So on this side, I get 100. And on this, this side, look what you've got. You've got x minus 5 times x minus 5. That's going to create the x squared minus 10x plus 25. So this trinomial is considered a perfect square trinomial because it can be written as a binomial times itself. So then for the first piece, we would have an x minus 5 squared. And then plus, you can see you can do the same thing with the y's. This would be a y plus an 8 times a y plus an 8. And if you factor this out, you get a y squared. You get an 8y plus another 8y gives you the 16y, and 8 times 8 gives you 64. So then I can write this as y plus 8 squared. And then this right here is our beautiful equation in standard form for a circle. So we're going to try one more of those. I would encourage that you pause the video and try to rework the example you just saw. By grouping the x's and y's, completing the square, and then rewriting it as a binomial squared. And then you can come back and try this last one. So for this last one, we have x squared plus y squared plus a 12x minus 18y is equal to 0. And I'd like to have the x's plus the y's equal the number. I'm going to try to complete the square for both of these sets. So again, the process is to take half of this middle term and then square it. So half of 12 is 6. 6 squared is 36. Add it to the other side to keep balance. Then half of negative 18. And when I square that, that would be negative 9 squared makes that positive 81. So I end up with the standard form is x plus 6 squared plus y minus 9 squared is equal to 117. So if someone asked, you would now be able to say, well, the center is at negative 6, 9, and the radius is the square root of 117. Now, 117 might have a perfect square. So 3 divides into 117 39 times. And so you can reduce this by a little bit. Okay? Now, the real question is, how did I know that that was a circle? So I'll leave a note for now. If the coefficients on the x squared and y squared terms are the same, then we know we have a circle. So some people, think even like this would be a circle. The reason I know it's a circle is because the x squareds and the y squareds have the same coefficient. If I wanted to put this in standard form, I could easily reduce everyone by 2, and then I could deal with this equation instead. And you would repeat the same process that you just saw me do. Any x's would get grouped together, plus any y's, and then the number goes on the other side. So in this case, there isn't anything to do with the y's because there's not a linear term. So we're just going to take half of 16 and square it, and balance it on the other side. And we get x minus 8 quantity squared, plus technically this is y minus 0 quantity squared is equal to 69, and the center is at 8, 0, and the radius is the square root of 69. So there's a nice brief introduction to circles. See you next time. X squared. And let's talk about some properties. We know the vertex is at 0, 0. And because this is a positive parabola, it opens up. We know that if we pick an x over here, there's a y value that goes with it. But if we pick the exact opposite x,
Hi everyone. This wasn't really how I wanted today to go, but I'm being detained and can't get to campus on time. So I'm making a video to replace our lecture today for circles and ellipses. It also contains your attendance grade for today, so please make sure you watch all the way through. So we are looking at circles and ellipses in section 8.2. You can get a circle by cutting parallel, excuse me, to the base of the cone, and you get a circle. If you cut diagonally through the cone, you get an ellipse, as long as it's not parallel to the side of the cone. So today we're going to look at circles and ellipses as part of our conversation about conic sections. I know you know this, but just a reminder, the definition of a circle is the set of all points that are equidistant from a fixed point. That fixed point is called the center, and the distance from the center to any point on the circle is called the radius. If you were centered at the origin, we've been studying these since we met each other, x squared plus y squared equals r squared gives us the equation for our circle, where the radius is length r. So here we have an example of a circle with a radius of 5 and the center at 0, 0. I'm more interested in circles that move, but our first example, very, very basic, x squared plus y squared minus 16 is equal to 0. If I rewrite that, I have x squared plus y squared equals 16, and so my r value is 4. And so to graph that, I probably would just pick the 4s that are on the x-axis, because if the center is at 0, 0, that gives me exactly 4 units in any of these directions, and then do my best, right? I'm not the best circle drawer, but do the best to make this look circular. Okay, so ta-da. So the center is at 0, 0, very boring. So let's look at what the standard form for a circle looks like. Standard form for a circle is actually x minus h squared, which we've seen that in our parabola work, and y minus k squared is equal to r squared. And this hk then is the center of the circle, and r is the length of the radius. So in this example 2, state the center and the radius of the circle, and sketch a graph. You can see that this is x minus h squared plus y minus k squared equals r squared. R squared is equal to 4, therefore r is 2, and the h comma k then is 2 comma negative 3. So to build this circle, we'll start at 2, negative 3, and then we'll radiate out 2 units to the right, 2 units to the left, 2 units up, and 2 units down to make our circle. Notice this circle is tangent to the y-axis. So tangent means that it's only touching it in one spot. That's foreshadowing. Sometimes the equation comes in general form, and your first step would be to rewrite it in standard form, and you might need complete the square to do this. So write the equation in standard form, find the center and the radius, and then sketch the graph of the circle. X squared plus y squared plus 6x minus 10y plus 44 equals 26. And our goal is to make it look like the form that we just saw. We wanted x minus h squared plus a y minus k squared, and then on the other side we're going to have some number. So let's set it up for that. We've got x squared plus 6x, leaving a space, y squared minus 10y, and then if I were to subtract the 44 from both sides, 26 minus 44 on this other side. Our job is to complete the square, so we'll add a 9 to the x's and a 25 to the y's. And we reviewed this in class already this week, so I'm not too terribly worried. But don't forget to balance it on the other side. Make sure that you do this balance statement, right? Okay, so now what do I have? I have x plus 3 quantity squared, and I have y minus 5 quantity squared, and now I need to clean up the other side. And I think I get something weird like 5. But let's just check me. This is 51, this is 60. Oh, I don't get 5 at all. I don't know where I thought I got that from. So 26 and 9 is 35, and 5 is 40. That's 60 minus 44. And that was really off. I get a 16, which is nice because that's a nice pretty number, right? So the center is at negative 3, 5. The radius is at 4. And that makes it quick to sketch the graph of 3 and 5 is way up here, and then you go 1, 2, 3, 4 in this direction, 1, 2, 3, 4 up, 1, 2, 3, 4 to the left, and 1, 2, 3, 4 down, and then we can connect those to make a beautiful dilapidated looking circle. Cool, cool, cool. This next example doesn't quite look the same because you'll notice that the x squared and the y squared aren't by themselves. But look, with all of these terms all divide by 5. So they're not fooling me. I can divide everything by 5 and rewrite a few things. And I am back to the exact same thing I had in example 3. So since this is a video, if I am talking too fast, it's because I had coffee and I'm stuck in this office and not allowed to leave because, well, it doesn't matter why, because, but anyway. And so I might be a little frustrated. So if I'm going too fast, just pause me, catch up to me, okay? So I apologize again for not being there today. Make sure you're paying attention for your attendance rates, okay? So now I need to complete the square. So I'm going to add 4 to the x's and add 1 to the y. That means I need to add 4 and 1 on the other side. When I rewrite this, this would be x minus 2 quantity squared plus y plus 1 quantity squared is equal to 9. It's not always a perfect square on the other side. So remember, it's r squared equals whatever that number is, and then you would square root that number to get your radius. So the radius isn't always an integer, but the center this time is at 2, negative 1. And they want me to sketch it, so I start with my center, and then I count out 1, 2, 3 to the right, 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 to the left, and 1, 2, 3 back down. So I'm not worried about the sketching part with you guys, you're going to be fine. But definitely practice your completing the square. The other thing they ask you to do in this section is they give you some information and they ask you to write the equation for the circle. So if I'm writing the equation for the circle, and I know the center, which is hk, the radius, which is r, this becomes just a plug-in type of situation. I need x minus 2 squared plus y minus 5 squared is equal to r quantity squared. So the only thing I would have to do to find the answer that matches on my quiz would be to square out the 2 and then square root 5. So that would be a 4 times a 5, which is a 20. So my final answer for this example would be x minus 2 squared plus the y minus 5 squared is equal to 20. And there's my standard form for a circle. It might get a little harder if they don't give you the center and the radius. In this next example, they do give me the center, h, comma, k, and they tell me a point on the circle, which means they don't tell me r. But remember, r is the distance between the center and a point on the circle. So if I do negative 1 minus 4 and square it, and then take 3 minus negative 7 and square it, if I square root that value, that is the r. So r is the square root of 25 plus 100, and that's the square root of 125. And then I'm not going to try to clean that up because look what happens. I get x minus h, so x plus 1 squared, and y minus k, so y minus 3 squared. And then that's equal to the r squared, and when I square the square root, see, I just get back 125. So a couple of examples of writing an equation for a circle, you need the center and you need the radius. And so we saw center and radius in this first example, we saw center in the second example, but we had to find the radius. In this third example, writing an equation for a circle, they give me the endpoints of the diameter. So they don't give me anything I need. So remember that on the diameter, that the center is halfway. So we're looking for the midpoint. So the midpoint would give me the hk. And you find the midpoint by taking the two x values and divide by 2, taking the two y values and divide by 2, you're finding the middle. So it's an average. So 6 plus the negative 4 over 2 and negative 3 plus the 7 over 2. And that reduces to 2 over 2 and 4 over 2. And that's a 1 and a 2, and that's my h, comma, k. So now I have this piece. Now I need the radius. You can do the radius however you want. For example, you could find the distance between the two original points and cut it in half, because the radius is half the diameter. If you're confident in your center, you could use the center in one of these points. I'm not confident today because my brain is elsewhere. So the diameter would be found by doing the difference between the x's. So 6 and negative 4, I need to look at the difference between those, and negative 3 and 7. And so that gives me 6 plus 4, which is 10. So I've got a 10 squared, and I've got a negative 10 squared. And so the diameter is the square root of 200, which means the radius is the square root of 200 cut in half. So now I'm ready to put all of this together. Remember, I'm lazy. I'm not going to clean anything up until I have to. So x minus what? X minus h squared plus y minus k squared is equal to my r squared. And my r was the square root of 200 over 2. So if I'm trying to make that look nicer, what do I get out of it? The square root squared, it leaves me 200, and the denominator leaves me a 4. So that reduces to a 50. And so I'll put my final answer here, but it's x minus 1 squared plus the y minus 2 squared is equal to 50. Okay? All right, this next one uses the idea of being tangent to the x-axis. So I mentioned earlier that being tangent is going to come into play. And so what is the equation for the given circle if you know you have a center at 2, 3, but it's tangent to the x-axis? So let's draw that out. And I still
Hi everyone, welcome back. In section 8.1, we want to look at parabolas. And I want to start with the basic parabola that you know. You are familiar with y equals x squared. And let's talk about some properties. We know the vertex is at 0, 0. And because this is a positive parabola, it opens up. We know that if we pick an x over here, there's a y, and welcome back. In section 8.1, 1, we want to look at parabolas. And I want to start with the basic parabola that you know. You are familiar with y equals x squared. And let's talk about some properties. We know the vertex is at 0, 0. And because this is a positive parabola, it opens up. We know that if we put an x over here, there's a y value that goes with it. But if we pick the exact opposite x, Hi everyone, welcome back. In section 8.1, we want to look at parabolas. And I want to start with the basic parabola that you know. You are familiar with y equals x squared. And let's talk about some properties. We know the vertex is at 0, 0. And because this is a positive parabola, it opens up. We know that if we pick an x over here, there's a y value that goes with it. But if we pick the exact opposite parabola that you know, you are familiar with y equals x squared. And let's talk about some properties. We know the vertex is at 0, 0. And because this is a positive parabola, it opens up. We know that if we pick an x over here, there's a y value that goes with it. But if we pick the exact opposite x, the same y value matches. So we consider this a function that has even symmetry. The definition is officially f of negative x equals f of x. But there is clearly a line of symmetry here. Straight